Hello, ladies and gentlemen. Welcome to episode 7 of the Indo-Pacific series with My Security Media and the Aerospace and Defence Consultants Association of India. My name is Chris Cubbage. I'm the Executive Editor and Director for My Security Media, and we're joined by Raman Sapuri in Delhi, our co-host. Raman, thank you very much for joining us.
Thank you.
Good to see you. We're here from Sydney, Delhi, and then we've also got a couple of guests from Brisbane and also in Singapore. We cover off on aerospace and defence and security technology market trends, opportunities between India, Australia and ASEAN. We do have 4 key domains: aerospace and space, defence and national security, cybersecurity and critical technology, and cities and infrastructure. And as I said, this is episode 7. We are in the defence and national security domain, but it's also a bit of a mix. We touched on drones and robotics, cybersecurity and in space. And in this particular episode, we're going to be covering off on robotics and autonomous systems in the maritime defence and security applications. I'd like to welcome our panel, Mr. Andrew Yu, Vice President, Unmanned Maritime Systems with ST Engineering Electronics in Singapore. Andrew, thank you very much for joining us today.
Thanks for inviting me.
Very good. And Dr. Stefan Hrabar, CEO and co-founder with Emesent in Brisbane. Stefan, thank you very much for joining us.
Thanks, Chris. Great to be here.
Great. Good to see the audio is working as well. And Martin Keetels, National Manager of Robotics and Innovation. And Martin, last time we met, I beg your pardon, I couldn't even say the word Konica Minolta. And since, once you become live to a company, you kind of continue to see it. So it rolls off the tongue for me now, mate.
Thanks for having me, Chris.
Good. Martin's also in Brisbane. Just 1 second. We were going to be joined by James Angelus, and he's just texting me now. Let me just double check before we move on to make sure that he's actually coming on. No, look, I'll check that. We'll move on and I'll check his messages. But we are hopefully going to be joined by James Angelus, who's the President and Representative Director with the International Security Industry Council of Japan, based in Tokyo. As we normally do, just a quick background to what we've been doing. Episode 6 last week, we looked at cybersecurity collaboration with our guests from ST Engineering again, and also Nokia in Singapore, as well as Group IB in Singapore. And Andrew Dinter, VP Industrial Security from Waterfall in Canada. That session was really covered off and almost was a good segue into this particular session where we looked at 5G networks, OT cybersecurity, and the cybersecurity threat landscape. And when we look at robotics and autonomous systems, cybersecurity obviously plays a key part in that moving forward. The week before, beg your pardon, let me just check back. The week before, this is not working for me, here we go. We covered on drones and anti-drone technology, predominantly looking at the Israeli and the Indian technologies here, but obviously these episodes are coming together quite well in terms of viewing and where this technology is actually leading us. So drones and anti-drone technology, and maybe we'll even touch on the robotics side and how the drones are. And I know that Stefan will be covering off on a bit of the drone technology as well from Australian research. And then the week before, space tech and leading trends. And again, that was a great episode on space. And I'll touch on what we're doing next week at the end of this particular episode. We are covering off on space again next week. And it looks like we've got a couple of real hot guests joining us from Australia and in Europe. So just some news on the week. Australia and India have just finished some naval exercises. They completed the Regional Passage exercise, and these are sort of several months culminating and finishing up in October with the 2 navies working there. In the picture is, Sayadri, HMAS Hobart and INS Karmak sailing through the Northeast Indian Ocean. Also, the Australian and Singapore navies have just completed, this was news out today, exercise Singaroo. This is the 25th year of this bilateral exercise. And again, HMAS Hobart has been working hard up there also. And some other news came out on Friday, Operation Argos. This is the United Nations Security Council sanctions on North Korea. Australia has committed to that once again with their P-8A Poiston Maritime Patrol aircraft deployed as part of that operation with the Konica Air Base in Japan, the operation point. And some news in defence as well. I'll mention Australia first. The 2021 Australian Defence Sales Catalogue to get into that particular catalogue has been extended by, I think, a week. So submissions are open until the 4th of October. And Raman, maybe talk us through the Defence Acquisition Procedure, DAP 2020, and we'll touch on this in future episodes as well.
Thank you, Chris. Just to share with the audience, India is the second largest buyer of defense equipment from all over the world. Yesterday, the Indian government has announced a new defense acquisition policy called DAP 2020. And this is going to be a turning point in the opportunities for global defense companies. The global who's who is already there in India, starting from Lockheed Martin, Boeing, Dassault, and then many leading companies from Israel and many other countries. What they have done is that they are going to freeze this acquisition process for the next 5 years. And we are going to cover, between me and Chris, a separate webinar only on understanding the new policy framework. But 3-4 takeaways are: number one, ease of doing business, ease of doing the trials by the customers, and the opportunity for foreign direct investments. I could say, with my experience of last 24, opportunities, that this year 2020 to 2030 will be the golden period for any defense company. If you are not in India, you are missing the huge opportunity at all. Drones, aircrafts, ships, missiles, space, all opportunities are available, and Indian government is now opening the opportunities, and then there's a huge part of opportunities they earlier do. And February 2021, we're going to have India's largest Aero India show in Bangalore. So I welcome all the panelists and all the participants to be in Bangalore in February first week. And with that introduction, over to Chris. Thank you.
Great. Thank you, Raman. Yeah, we will dive into that a bit more in a separate episode, but interesting news nonetheless. And this was an interesting tweet, just in terms of the bilateral sort of meetings going on. I know it's probably maybe a little bit hard to see there, but official meetings are happening between Australia, India, Japan, and the US. This is obviously in the last week with the Quad. Then Australia, India, and the US weekend with the Prime Minister of Japan. You got PASEX between Australia and India. You got GIMEX between Japan and India, and then the ambassador meetings in Brussels of the actual Quad. And then over the last month, France is in there too with a trilateral meeting between Australia, India, and France. Foreign ministers meeting between Australia and Japan, as well as India and Japan signed the AXA. So there's a whole bunch of stuff going on. This is a very interesting tweet from Tanvi Maiden, just to put a picture to particularly the Quad. And that's one of the reasons why we've got James coming on with us today. Following the Indo-Pacific series, we're going to look at doing a Quad series for at least 4 episodes, being at the Quad, and we'll dive into how these relationships are forming. So there's a lot there as well. And in this particular space, there's a lot of opportunity for advanced technologies. We cover off on robotics on our Drastic channels, drones and robotics. So Drastic stands for drones, robotics, automated systems, technology, intelligence, and communication. So, and welcome, James Angelus. Thank you very much for joining us. I think we've got you on audio too. No audio yet, mate. We'll come back to you, James, once we start under the presentations. We can't hear you yet. Try, if you don't mind, sign out and come back in and see how you go. Just one more time. Yeah, we'll have to bring him back on. So again, with drones and robotics, because we cover so much, if you just put in robotics in the search field, all of the robotic related stories come up, and you can see there Konica Minolta has been a regular feature as well. Some other news, the infrastructure as a service revenue in APAC to grow by 11% over the next 3 or 4 years as well. You see India there has a lot to grow, but Japan and Indonesia are leading the way in terms of their annual growth rates. This other interesting news in terms of Incron. Now, these are working on particularly new investments in the nano imprint lithography materials, which will give us new capabilities in augmented reality glasses and 3D sensors. So that's news is on drastic as well, but very interesting in terms of this technology and where we are moving rapidly. And a couple of robotic stories. Hitachi has begun testing of the 5G-powered IoT solution in Silicon Valley. And this is a new robotic arm out of the University of New South Wales. Beg your pardon, so a robotic hand, and it's been applied in the construction industry as well with some University of New South Wales master's students. I'm going to actually reach out to them. Raman had an interesting story on a robotic arm in India, and in a couple of episodes we're going to try and get these two together, one with a robotic arm and one with a robotic hand, and see what we can do together in terms of that particular episode. So that's pretty much the news of the week on our channel. Just some events that we've been covering. Communicasia is on this week, and mobile network operators are to hire and reskill 1,000 professionals in Singapore as part of their 5G. So there's a lot happening in the training area there. That's the Infocom Media Development Authority, IMDA, has partnered with Singapore's mobile network operators to reskill 1,000 professionals at least. Black Hat Asia is also on this week. Starts today, but I think the conference actually is on tomorrow full swing. And then we've also got tomorrow celebrating 40 years of the Ethernet from 2.94 megabytes per second to 800 gigabytes in a matter of 40 years. IBM Security Virtual Summit ASEAN should be maybe closing off. We might get a couple of weeks more out of that, but that summit is available on demand on our channels as well, covering off on cybersecurity, obviously. And this episode will come out on Thursday, an interview with Bill Nelson, the CEO of the Global Resilience Federation. I believe he's in San Francisco, just in the cyber threat intelligence landscape with Bill there. Finally, the top women in security in Malaysia. The nominations are open for a few more weeks. We've got 3D Printing World in India on the 5th and 6th of December. And just some recent reports that have been put up onto the marketplace recently. This was an interesting one, security guidance for first responder mobile and wearable devices. Obviously, there's tracking capabilities that you need to be able to turn on and off with this. So yeah, an interesting one. And also another one was the Developing the Future for Asia, and it's one of the reasons why we do these particular series, to bring Australia and India and the region together and learn from each other. So look, that's enough from me and enough from the marketplace. We're going to be joined now by Andrew Yu.
Thanks for the invite, right? So, good morning, good evening, and good afternoon, wherever you are joining us. So I'm very glad to be invited to this series, to share a little bit on all these autonomous and technology stuff. In specific, my company, we have been developing surface vessels and autonomous surface vessels for quite a number of years, right? And I'm here to share with you, some advancement or some commercial kit, right? That over the years, we have actually streamlined and actually converge all the value onto. Okay. So how do I manipulate my screen? Just a minute, yeah. I'm a little bit foreign to this, so yes, right. So I'm here to introduce a self-piloting kit, right? It can be fitted to both manned vessels and autonomous vessels, right? So we pack all the sensors onto a mast, right? Sensors are equipped with cameras, optical system, navigation radar, and data link systems. Okay, to provide 3 of the functions above: automatic object detection, collision avoid capabilities, and finally guidance and navigation. right? So this particular kit, right, you can install it on you know, any vessel, right? And to give you some perspective, right, a vessel of 10 meter size can easily fit ISO container of 40 feet, right? So to give you a little bit of scaling, that's how a kit actually looks like, right? So it's easily transportable, right? You can pack it into a shipping container, and at the destination, you just need to fit this kit onto a vessel, right? Then voila, out of the box, you get autonomous navigation capability. Okay, and within the wheelhouse, you know, the navigation electronics, right, is packed within a seat plus kind of a real estate footprint, right? So if you have an existing vessel, remove one seat, fit this box in, right? So this is actually powering the whole sensor fusion and the whole autopilot system on board the vessel. Right. So these are examples of you know, interested parties, you know, that want to actually build a boat or retrofit a boat with the autonomous kit. So on the top right hand corner, the size of the vessel is about 9 meters in length. At the bottom left hand side, the size of the vessel is about 15 meters in length. Okay, and interesting applications could include search and rescue, right? If you want to modernize search and rescue operation, right, which can be very arduous, long duration and all that, and you have to probably do all these operations 24/7, even until nightfall, right? Maybe trying it to equip with the autonomous technology is the way to go. Likewise for firefighting, right? If you need to put a vessel against a oil tanker fire, right? Maybe to unman a firefighting vessel is another way to go. So the human need not be on board this firefighting vessel, but can operate the vessel at a standoff distance. This is how just an example of how the shore control or the remote control station look like, right? There's a mission planner. At the same time, there's a safety manning for remote piloting, right? So situation awareness of what the vessel sees in terms of navigation is constantly streamed, right? And most of the time, there's no need for intervention because most of the maneuvers and movements are autonomous. But you know, but sometimes the emergency handling and the emergency takeover functions are still available. On the other aspect, we also augment metadata onto video streams. So over the years or many years of development, right, we also understand that, you know, we try not to pass the hot potato to the user at the last bit. So for the robot to interact, you know, with the human, to give sufficient time for the human to respond, is also for the robot to report, you know, what it actually sees and what obstacle it registers. So what you see in this particular video, right, is basically the robot sees all this track number, right? So if there's a number, means that the robot sees this as a threat or an obstacle, right? So the human, when he's actually supervising the navigation, is actually forewarned of what's coming ahead, right? And here I'm just going to play a video of how we actually enhance, make use of optical capability, right, for very small object detection. So what you see in this video, you know, are basically, you know, laser sailboats. I think they are like 3 or 4 meters in length, very low profile fiberglass. So with the autonomous, right, if it's fitted onto the correct vessel, small object detection, you know, we can detect all these surface obstacles and navigate around them. All right. So yeah, besides all these perception, collision avoid capability, right? The autopilot is also designed in such a way that you know, we prevent a runaway scenario, meaning that the vessel, if there's the starting point, right, at the last waypoint, the vessel typically anchors itself, right? So if you forgot to plan a waypoint subsequently downstream, right, at least you don't lose a boat, right? So the vessel automatically anchors itself, but there are many other waypoint schemes that we can manage the vessel in terms of voyage, right? We can actually do a loop, right, or reverse, you know, we can actually command the boat to do reverse. So depending on whether is it like firefighting, a firefighting scenario, probably you want the vessel to navigate until the last point and stay there for firefighting. But in a search and rescue scenario, you probably want, the vessel to swim in loops, or actually reverse, right, to increase the probability of search, right? And how easy is it to fit this kit is really not that complicated. It takes about half a day to fit it on, right? And by the second day, you can actually put a boat in water and test out all these capabilities. Okay, so it readily fits onto any vessel with with the appropriate mounting, right? So long as you have a cabin space within to house some of the electronics, right? Then you can actually get an unmanned vessel quite out of the box. So here I'm just trying to show that we have different autonomous sizes to cater for different vessel sizes. Okay, and the propulsion or the hull form actually can vary. We just tweak some of the dynamic equations to still achieve the same guidance performance. And I think the autonomous is suited to automate the whole maritime surface application in these various aspects, whether it's in defense, maritime security, oil and gas, fishery, or even firefighting. So with that, I actually end my presentation and welcome any questions.
Many thanks, Andrew. I don't have any questions from the audience, but I was going to say, how small can the objects be to be detected? Is that something that you can adjust in terms of its sensitivity?
Yes, yes, we can. And in fact, very low observables, right? I mean, if you're talking about floating coconut, that's possible to even detect a floating coconut.
And what about aerial sort of connectivity with sort of aerial systems as well? That, is it communicated to any other system, or is it a standalone, I suppose is the question, or can it be integrated with other systems?
Yes, I mean, what we sell as standard is actually a standalone system, and we are selling this commercially as a commercial product, right? But of course, if it requires heterogeneous operation and further customization, then we can talk about it on a project basis, right?
Great, very good, very interesting. And let me just bring that. Any other questions from the panel on that particular one as well? Go, Rahman.
What is the source of fiberglass?
Oh, you mean the mast? Sorry, I can't hear you.
Rahman,
what is the source of fiberglass?
The source of fiberglass.
What do you mean? You mean what is the material of the mast?
Yes, material. Yes, material.
Material. The material of the mast is aluminum, right?
Okay. You mentioned about the fiberglass. I was just wondering.
Oh, fiberglass. I mean, it can be fitted to a fiberglass boat or aluminum boat. It really doesn't matter what material the boat is made of.
One supplier in India, which is doing this fiberglass work, is wanting me to connect to you. I'll send the details to you. Thank you.
Great.
Well done. Thank you, Andrew. Very interesting. I've seen some similar systems out of Israel as well. So yeah, very, very interesting. I suppose the other thing is there anything unique to that technology? You're using off the shelf and then applying it in a maritime situation? Is there anything different in terms of how that technology is working in a maritime environment?
Yeah, I mean, we are optical centric system. We use a lot of cameras, and with that, I think we are very compatible with all the modernization of compute technology, right? If you talk about AI, object recognition, training rules of the roads, corex, and all that. So we are optic centric, and we are building a lot of backend engines to support all these initiatives.
Okay, so there is a lot of video analytics involved in that, yeah. Very good. Okay, well, look, we'll hand over now to, and I've fixed this particular system now. Stefan, are you okay for me to hand over to you?
Yeah, sure. Right. Well, yeah, thanks again from me for the invitation to be part of this panel. Looking forward to just, I suppose, explaining a little bit about who we are, what we do, and some of the use cases that our technology can be used for, and then definitely happy to answer questions as well. Just to start with a little bit about the company. So we're a fairly young company. We launched in November in 2018. Prior to that, myself, my co-founder, and a couple of the technical team were with CSIRO. CSIRO is the Australian National Research Organisation. We've been doing research on autonomous drones there for more than 10 years. And then we spun out with VC backing in 2018. Based in Brisbane, now up to 42, and we're hiring constantly, so always looking for good talent. And I suppose, our core expertise already in the drone autonomy side of things, and then also doing LiDAR mapping using our SLAM algorithms, and then analyzing the data that's collected by these systems. So the key problem that we're looking to solve is collecting data in challenging GPS-denied environments. Basically, areas where it's hard to access, there's no GPS, no or little comms, and no prior maps. And use cases across different verticals. A big focus for us is underground mining, and we've got strong traction there. But the system is also used in other sort of underground environments for civil tunneling, indoor environments, again, where you have no GPS, obviously search and rescue, or even in urban environments where you have GPS problems because of the buildings. And we've had more and more interest from the defense side of things. So now we're looking sort of into the defense aspects as well. So our solution for this problem is, it's actually interesting listening to Andrew's talk, because it's kind of like we're doing the Autonomast for drones. Very similar concept. So this is a modular payload, which includes sensing and compute, which you mount onto a drone, and by doing that, it provides autonomy to the drone. So we're using a Velodyne LiDAR up front, and we actually rotate that LiDAR to give a full 360-degree field of view for the drone, and that allows it to avoid collisions in all directions. And also, we just use the same data for autonomy and for generating a data output. That's the 3D map. We also use the LiDAR data in real time running through our SLAM algorithm to estimate the state of the drone. So that's position, velocity, attitude, and we use that instead of using GPS. So that's how we allow sort of drones to fly in these GPS-denied environments. And obviously, it's doing active collision avoidance, path planning. Everything's happening on board this device, which is mounted to the drone. So that's just what it looks like on a typical drone. So this is a DJI M300. So our autonomy is compatible with a couple of DJI drones at the moment, and we're adapting that to other non-DJI drones as well, based on the Pixel autopilot, and we'll be releasing that capability soon. It can be deployed on other platforms. So, it's built primarily as a drone autonomy platform. But because it's modular, we can take this off, we can put it on a surface vessel. The one you see there, it's not automated by HoverMap. There's still somebody sort of remotely operating that, but HoverMap is acting as a mapping sensor. And the same with various ground robots, whether it's the Spot Mini or wheeled robots or tracked robots. For now, HoverMap can act as a passive mapping sensor on those devices, but in future we will be able to adapt our autonomy stack to automate those vehicles as well. You can also just use HoverMap as a handheld or backpack-mounted scanning device. So it's a standalone mobile mapping device as well. So very versatile in its deployment options. In terms of the autonomy, I suppose the key thing that allows, like I said, the drone to fly without GPS and also travel beyond line of sight and beyond communication range. The way it's operated is through a tablet. So once it's up and running, we stream a live 3D point cloud to the tablet, and you simply tap in that map to set waypoints, and then the system self-navigates to those waypoints while it's avoiding collisions and keeping itself safe, keeping track of remaining battery life or looking out for sort of very challenging environments where there's too much dust, and has a number of fail safes which will trigger a return to home if it encounters those kind of situations, and it'll find its way back home safely. And just a couple of examples. So this is an example in an underground mine where they needed to go and map and inspect an area that they couldn't access on foot. So in many cases, there's areas in a mine which are too dangerous to send people. There might have been an incident or an area that's just freshly blasted and they can't access. So this is a top view, and you can see the line showing the flight path. So the operator stayed behind a barricade and sent the drone off exploring down these areas a couple of 100 meters, and managed to map out those areas without putting people in harm's way. And this video, I'm not sure how well this is going to come across, but it's just a quick animation fly through of the data that was collected on that flight. So you can see the level of detail that's captured by this LiDAR device. In probably 10-15 minutes of flying, we can map out areas like this in extreme detail. Another video just shows how harsh these environments can be. So this is an application in a mine where they needed again to go and enter an area that was off limits. It's where they've been blasting in an area called a stope. So it's a big cavity that's formed underground after blasting. They need to go and then basically take a measurement to see if the blast went according to plan. So send in the drone. It's flying autonomously now. It's encountered challenges like this: dripping water. There's rock bolts and wires hanging from the roof. There's wire mesh that can be an obstacle. And all the operator has done is set a waypoint somewhere way in the distance, a couple of 100 meters away, and it's now self-navigating to try and reach that obstacle. That waypoint. You can see it's avoiding hanging wires from the surface and trying its best to get into this area, mapping in all directions as it goes. And you'll see now one of the big challenges for underground. So the drone downwash can kick up dust. It's entered in an old area which is very dry. It's kicked up a lot of dust. And now the systems realize that it's getting into a challenging environment where the sensor, the LiDAR, could be blinded, so it's not safe to continue. So it triggers this automatic return to home response and basically flies its way back to the operator, obviously still scanning and collecting data as it goes. So I'll skip through it to the end of that. Finds its way back home. So that's just one example of how the system can be used underground. And this is just a section through the data that was captured for that flight. So you can see it's flown through this area, hit the water over here, and then flown into another void and eventually hit the dust and come back home. Just another example of an underground environment that was mapped with the beyond line of sight flight. You can see the flight path there. So really getting into these areas that they just have no other way of being able to map. It's just too dangerous to send people into these areas. This video is also just to show some of the other work we're doing together with our partners at CSIRO. So we still collaborate with the group that we were previously part of. Together, we've been accepted into the DARPA Subterranean Challenge. So this is one of the latest challenges set out by DARPA. And the challenge is to send in a team of autonomous systems into an underground environment to map, explore, and locate features of interest, and then report those features of interest to an operator. So an operator has to remain outside the entrance to a mine or cave environment and control a team of robots that are working together to go and map and find things. So this video shows the capability we've developed. So we focus on the drone capability, and then CSIRO focusing on the ground robot, but together these two systems work together. So I'll just play through the video and you'll see how the system is deployed. First of all, the drone gets a piggyback ride on the ground vehicle to preserve drone battery life and to squeeze through tight areas that would be too small to fly through. And then once the system's entered into a larger area, the drone is deployed by the operator and basically then goes exploring. So this is what we call autonomous exploration. It's a single command from the operator. He's just pressed launch and now the drone is on itself, by itself, mapping and exploring and looking for areas that it hasn't yet explored. So it's using the LiDAR to find out where these areas are, but we also have a gimbaled camera on top of the drone, and that's scanning backwards and forwards looking for features. And here you'll see some examples of features that have been detected: backpacks, people, anything that could be of interest. Obviously, part of this video is sped up just for the sake of time, but it gives you an idea of how capable the system is to explore these very tight areas. There's no protection around the props. We're relying purely on the LiDAR to detect those obstacles in all directions. This is a test we did just prior to the actual competition event, which was held in another location. And there's sort of 3 stages to the event. This is the indoor part, and then the next event will be the final event will actually be in an underground cave environment, and that'll be happening next year in the US. So basically, this drone flew around for, I think, around 15 minutes in this building environment, exploring all by itself, while the ground robot also continued exploring on the ground. And together they share maps through a mesh network which is formed between the two. The ground robot also deploys communication nodes, which help sort of strengthen that mesh network. And all that data is sent back to the operator. The operator sees a rough sort of view of what the drones and the ground robots are seeing, and then just gives very high level commands like, try and explore here, try and go there. And then the systems are sort of on their own to explore. So again, you can see it sort of getting through some very tight spaces as it explores this building environment. Eventually, I'll just skip forward a while. It triggers, the battery runs low, so it triggers a return to home and goes back to land. Actually, yeah, you can see the two systems working together, the drone and the ground robot exploring this area. So now it's heading back home. It doesn't yet land on the ground vehicle. It'll just land somewhere by itself, as long as it's close enough to stream back through the mesh network all the data that's collected, and score points for this for the competition by identifying those features. And I'll skip forward to this is the data that's actually collected. So again, this is a 3D point cloud rendering of the data that was captured during that flight, and you can see the flight path of the drone as it went down exploring these passages and other areas, winding its way through sort of very complex infrastructure. So in terms of the competition, as I said, we've been through the 2 competition events so far and done really well. We've been in the top 5 for both events. In terms of the drone capability, other teams have also deployed drones, and we've performed the best of the drone-based capability. In the last event, it was in an abandoned nuclear facility, and you can see this partial map down the bottom showing how the drone flew from one floor down into the other floor and then into various rooms to map them and locate these features of interest. So doing really well, and this has generated a lot of interest for us in the defense space. Just a few examples of what can be done with the data that's collected. In some cases it's a mining use case. Number 1 here is actually classifying the point cloud to locate rock bolts. So these are the bolts that actually hold up the ceiling and support the ceiling for the mine. And it's important that they have a certain number of bolts in the right space. So by scanning and then running analytics on, we can do an audit and make sure that they've put the bolts in the right place. Number 2 is the capability for DARPA, where we're using, train the image classifier to locate features of interest, such as a person, and then report the position back to the base. And then a big one is change detection. So if we've scanned an area once and then come back later on and scan it again, we can basically tell what's changed in that environment by aligning the scans and then just doing a heat map between the two. And this is applications in the mining space as well. For example, this is an area that a new tunnel was blasted, and then they put shotcrete layer on, and by comparing the two, we can show them the thickness of the shotcrete to make sure that it was sort of applied in the right amounts. So in terms of commercial applications, I've mentioned mining, but there are many others that have this common use of capturing 3D data in a rapid, easy way where there's no GPS. And you can see some of the examples here. And I'll just go through a few more in a little more detail. So this is capturing sort of detailed as-built of large infrastructure above ground for mining as well as the underground. Another example is indoors. So this is indoor stockpile. Again, this is interested in the volumes, but they can also assess the condition of the actual structure as well by flying around in there. Urban environments. Here I've took the system for a walk and walked above sort of at street level and mapped the streets in the building, and then I walked down into this subway station and mapped underneath. So because it's SLAM-based system, it doesn't matter if you're going above or below ground, we can generate a complete as-built. Other large sort of critical assets like bridges, you can capture the 3D data, but the hover map also allows the drone to fly safely underneath them to capture high resolution images as well. Other examples of power infrastructure that need to be inspected and maintained, all using a hover map to keep the drone safe. And this is another example flying inside a hydro power plant again to inspect it and generate an as-built. Another interesting one is, again, capturing quick digital twins of assets. This is a walk around 737, walking around the outside and then inside to generate a digital twin of that asset. Or naval vessels as well. So this is one strong use case, is to capture as-builts of these vessels so they understand what's on there, because the blueprints might have been out of date.
Have you, sorry, Stefan, have you tried to match the sort of the CAD drawings? You talk about digital twins for infrastructure. Have you actually overlaid sort of CAD drawings to some of these images?
We haven't done that ourselves. I mean, our customers do that. So our software just basically produces the point cloud and then can be imported into 3D CAD packages from Autodesk and Bentley and do that comparison. Yeah. This is an example where we had hover map on a surface vessel with a side scan sonar as well, and we could match up the above and below water scans and get a complete picture of a port sort of infrastructure.
Does it work underwater, Stefan?
No, this is not hover map. So hover map is LiDAR in the 905 nanometer range, and that will just be absorbed by water. So the underwater scan was done by a side scan sonar, but then we could marry the two up with hover map on the surface. Obviously, LiDAR by itself doesn't provide color information, but we can add color by mounting a GoPro, and we do a calibration which matches the camera to the LiDAR, and we then can project color onto the LiDAR point cloud as well, which adds some additional sort of context. And another thing we can do with, obviously depending on the drone, but you can carry a camera at the same time. And like I said, hover map keeps the drone safe while you're sort of capturing inspection images. Or in this case, this is a thermal camera on the drone flying underground. You can see water dripping through here. If you're doing search and rescue, you'd be able to pick up, thermal signature of people. So applications there for thermal in underground and obviously other search and rescue environments. Yeah, just mentioning that we've got a number of customers around the world. Many of the big mining companies are using hover map in their mines now, and a couple of other applications, and distribution network around the world who are supporting us and servicing and selling for us. And it's been used very widely, very strong track record in mines and other areas around the world. Yeah, I think I'll leave it at that, and obviously open to questions during the Q&A session as well. Thanks.
Very good. Thank you, Stefan. There was one question from the audience. How much depth, thickness of shot? I think they're talking about the concrete it can measure. I take it that's up to the payload that you're using, but the LiDAR is only surface level, isn't it? It doesn't go into...
Yeah, it's not penetrating, no.
Yeah, yeah.
So to see that thickness, we do scan 1, and then they apply the SHOTCRETE, we do scan 2, and we're just measuring the difference between the first and the second scan.
Got it, yeah. Go, Ramon.
Yeah, one customer has called me. He wants to set up a joint venture with you in India. Are you open for this?
Yeah, we're setting up distribution partners in India. Obviously a joint venture is a little bit different, but certainly happy to have a chat.
A lot of inquiries have been received on a mobile phone. People want to get back to you, a lot of opportunities. I think you might get the biggest order from India very soon. Looks like.
Okay.
As long as we get a cut.
Drone harmony in Europe, but yours is much ahead of this. A lot of scope for both military and non-military options. India is a goal for you. Please come as early as possible. Fly down to Delhi. I am sitting very close to the airport in Delhi. I'll receive you. You collect your check and go back to Australia. Happy.
Okay. No, that's great. Thanks for the feedback.
He's half serious, believe me. So just
I'm signing the check today for you. Come over.
I've just got one more question. Hang on, Stefan. How do you eliminate vibration and noise of the platform to stabilize?
So I presume it's talking about the control aspect, is hover map is mounted to the drone, and there is some vibration isolation in that mounting mechanism. And then internally we have some additional damping, but we can't have too much damping because we're estimating the state of hover map in the hover map's reference frame, position, velocity, attitude, and if that's decoupled from the drone, then the control loops will not work. So it's fairly rigidly mounted, but when it's acting as a standalone scanning device and we mount it on vehicles with a magnet mount or a suction cup, and then we have vibration isolation in those mounting points. So if it's on a mining vehicle going over really rough terrain, it gets shaken around pretty badly, but it doesn't affect the SLAM algorithm. Still behaves. We've got some results to show for that as well. I think that is what the question is to do.
I would think so. I think I had a couple of questions here before we move on to Martin. One was, you have actual avoidance systems on this, yeah? So my sort of key question is, how much is off the shelf and how much is new technology for this?
The hardware, some of the hardware components off the shelf, like the actual LiDAR, but all the software is ours. It's we've been building that for many years. The full autonomy stack is ours. Don't rely on anything off the shelf.
Okay, very good. Okay, well, look, we'll move on. Thank you so much, Stefan. Very, very interesting, and it's great to see some Australian technology there as well. I'm getting some background noise. I don't know where that's coming from, but I imagine we're okay. Now, Martin, you're okay to move on and take over? Not take over.
I am.
I've got your slides here. Excuse me. So I'm going to hand over to Martin Keetels. I'll run the slides. Martin, just let me know when you're ready to sort of move on, but you're going to cover off on the MIR robot and applications in defence and national security sectors.
Thanks, Chris. I might actually get you to play the first video, if that's okay. We'll use that as a bit of an introduction.
So set me a challenge straight away. Now, I couldn't find the question just before we go. Let me find this, because I believe, here we go. Press play.
SARA stands for Supply Assistance Robot Autonomous Hardware. It's a mobile industrial robot MIR 200 supplied by Konica Minolta. 36 Squadron is always looking for innovative ways to be safer and more efficient. The robot introduces efficiency by automating a simple part of our supply chain to free up our people to do things that only people can do.
SARA is used with an iPad and follows a pre-programmed route to take parts from supply section to our job controllers, flight line, tool store and life support. SARA has built-in safety features, so she will slow down in high traffic areas and if someone is getting a little bit too close. So with SARA, the team is able to focus their time on higher value tasks.
SARA can carry 200 kilograms total capacity, but with the shelving installed in our configuration, she can carry 150 kilos.
SARA has completed over 200 kilometres, which roughly works out to be 4.6 marathons in her time here.
SARA is the first phase of a larger program to more efficiently move parts from the warehouse to the technician. We're already seeing some efficiency gains, but hopefully the program is also encouraging our people to think big and think outside the box.
I'll be back.
Thank you, Chris. As you can see, Konica Minolta is a supplier of the mobile industrial robots here in Australia. MIR is a Danish company, and it's a market leader in manufacturing autonomous mobile robots. And these robots are a platform, and they have several different applications. You can see there that one of their main applications is moving things, and they do that differently to their competition, which you see here. We have the competition of an AGV, an automated guided vehicle, but also their competition of conveyor belts, forklifts, really any manual moving of trolleys, etc. And so what I want to talk to you a little bit about today is the difference between an AMR and some of those more manual options. But firstly, just let me introduce myself. So my name's Martin Keetels. I'm the National Manager of Emerging Technologies for Konica Minolta. Now, many people on the webinar may have heard of Konica Minolta before, and it may seem it's a slightly unusual product or service for Konica Minolta to be supplying. So KM's got a great reputation and brand for photography, but also for print management and solutions around the office as well. And it's because of that heritage of supplying maintenance services and solutions to such ubiquitous products that make us actually a really logical choice for being providers of not just robotics, but also 3D printing and other emerging technologies as they come to market in Australia. So we're able to leverage really mature infrastructure around maintenance and providing service to our customers to actually support these industries as they grow and support their adoption in a market such as Australia, which, similar to India, has a very large geography, quite distributed population. You know, Konica Minolta, for example, we have in Australian market, we have service capability in around 80 regional centres around Australia. Now, if you were to speak to a robotics manufacturer, an OEM, around setting up the same service infrastructure in a country like Australia, it just wouldn't be possible. It's not feasible, nor is it economic. So that's the reason why Konica Minolta is really leveraging our existing infrastructure in this space, and that's the reason why we play here. What I do now want to touch on is the difference between an AMR and an AGV. So you'll see there that an AMR is trackless, and one of the reasons why I believe I'm here today is the autonomous nature of this. So similar to what Stefan was talking about, the AMRs utilize SLAM methodology to navigate autonomously around their environments. A little bit different to that particular product, but when you're deploying the MIR robot, you set it up in a mapping mode, and the mapping mode, as it scans the environment in which it's operating, it looks for both dynamic and static objects, and it utilizes static objects as a way to create localization. So it understands where it is at any particular point. It looks for a familiar object, a static object in the environment, roughly every 12 meters that it travels, and that's how it's able to localize itself. One of the great features of the AMR is it has a port on board, and we're able to connect to the AMR utilizing any smart device. So whilst there's one robot being utilized in a particular area, there's no need to have software on a server, and you can connect directly to the robot. But there you can see it travels safely around people and objects. It's easy to expand and change the work area. In fact, one of the big differentiators of this particular product is that to commission a new mission, as we call it, in this field, it takes minutes, potentially hours, certainly not days. And certainly, if you were to recommission this technology, you know, move from one facility to another, for example, instead of it costing hundreds of thousands of dollars and losing months in redeploying this technology, it's literally a day or two's task to set it up in the new environment, getting it to do new missions, and as a result, it's really an effective additional team member for new environments and for existing environments. So it's able to work within greenfield and brownfield sites, really simple and easy to deploy, and service providers such as Konica Minolta are able to train up local staff so they're able to deploy the robot more broadly and have this new digital team member doing more tasks. Compare that to existing technology that's already in the field, such as AGVs. These things require tracks or magnetic strips, etc., QR codes, that sort of thing. It has to stop at obstacles rather than moving around them. The AMR is able to avoid obstacles and find alternative routes. Really expensive to commission and repurpose, and it's restricted to fixed routes and controlled sequencing. So, Chris, I might get you to move through to the next slide, if that's okay.
By way of explanation, the video you saw at the start is the deployment of a MIR 200. So that's one of the platforms that holds up to 200 kilos. Now that's at the 36th Squadron at the Royal Australian Air Force in Amberley. You know, the part of the acquisition of that particular item was conducted through Air Force's innovation arm. So, you know, we're really seeing the Australian government and in fact the Defence Force hungry to test, acquire new technology and really move its capabilities into you know, the next century, utilising Industry 4.0 technology. So that's incredibly exciting and something that we're incredibly proud to be working with the Defence Force. I'll quickly run through the types of robots that the MIR OEM manufactures. So you can see there the MIR 100-200, which is on the left-hand side of those screen. Really payload 100 or 200 kilos per the naming convention. You can see there it moves at speeds of up to 1.5 meters per second. So a fast walk, running time of 8 to 10 hours, and charging time really of 2 hours to get to 80%. So you can see there that utilizing this sort of platform instead of having someone move a trolley or you know, taking up a valuable person's time moving things, that this product would certainly very quickly make financial sense. You also then add the safety element to this, which is that you don't have people pushing or pulling heavy weights, and as a result, the people around your environment are safer. So from a work cover perspective or an insurance perspective as well, there's certainly a lot of value add here. And then on the right-hand side, we see the MIR 500 and the MIR 1000. So they're capable of moving pallets or heavy material and move at 2 meters per second, similar running time and battery times. So these things are capable of being deployed in military areas, security areas. You know, one of the beautiful things about these products is that you know, they're able to operate in harsh environments. You know, so long as they're operating indoors and they have a relatively flat floor, then they're able to be an additional digital team member, whether it's a military application, a security application, or indeed a civilian application. Chris, I might just get you to go to the next slide, and whilst you're doing that, I'm just going to give a quick explanation to this. So this is a video of a 3D emulation software that we've recently acquired. You'll see here this is the movement of palletized product around a warehouse. It doesn't matter, once again, if it's civilian or military applications, but essentially this is a way to automate pallets. In this particular example, moving from a palletizing unit that sits on a conveyor and around 200 pallets per shift. So there's an 8-hour shift being moved from that palletizing location to a staging area. At the end of that staging area, they're put onto a conveyor, an accumulation conveyor. That accumulation conveyor, from memory, has about 13 or 14 different locations for those pallets, and then they're moved onto the back of a truck for transport to their final location.
Okay, here we go.
So we can see here it's a bit of a fly around, we can see there it's moved through the palletizing machine. Does a quick
We did have a question
here
as well. What dimensions are they, Martin?
They're roughly 1.2 by 80, something along those lines, depending on the different model. But that's probably one of the larger ones.
And I take it you can put different sort of platforms on top, you know, to make that,
that's right,
that base bigger.
Yeah, yep. We call those top modules, and there's an ecosystem that's developed around the MIR product. Available on the MIR website, or indeed on the Konica Minolta website here in Australia. You can go to the MIR Go part of that, and that's the ecosystem of top modules and solutions You know, something that's also worthy of note here. So there is some physical integration that's happened here, but there's also digital integration. So there's a PLC that the robot is through an open API platform. It's basically integrating so that the PLC in the conveyor is actually sending a digital signal to the robot to say, I'm ready, and then the robot's sending a digital signal back saying it's been collected.
So how many would be out in the field now? I might take it it's not too commercially sensitive, but how much are these out there now?
Circa 5,000, Chris?
75,000?
No, circa 5,000.
Oh, circa 5. Okay, that's all I'm going to say. I'm impressed if there's 75,000, but okay, that's pretty good.
That's my sales target for next year. So no, we'll see how we go against that.
And that circa 5,000, that's worldwide or here in Australia?
Worldwide. Yeah.
Okay, very good. Not too bad at all. Let me just get this going again.
Great, and that's pretty much all I wanted to share with the audience today. If you have any other questions, delighted to take them.
Very good, thank you, Martin. I don't have any questions from the audience other than the ones I asked. Is there any other questions from the panel on this before we sort of wrap up the robotics and autonomous systems? I think from my observation, it looks like they use very similar technology, obviously the LiDARs and the video analytics and the like. I suppose the real smarts is how you get that software talking to each other and bringing these systems together and actually deployable. One question, Andrew, is your system is commercially available as well?
Right.
Very good.
It is commercial. Right.
Okay, so look, all of these systems are commercially available. And I think we'll obviously have anyone from the audience who is interested in making a link through to these gentlemen, please let us know as well. James, did you have a question there? Sorry, James, 1 second.
Yeah. I have a question, Chris.
Go, Martin.
Oh, yeah, James, sorry.
Quick one is, how are you set up with KM in Australia? As a representative of KM or as a joint venture, or are you independent and have just a contract with them, a distribution contract? What's the nature of that relationship?
Yeah, so thank you, James, for the question. We are the distributor in the Australian market. Indeed, we're a distributor in the Asia-Pacific, most of the Asia-Pacific economies as well. That's given us the ability to also be developing some software around this product. So we've got R&D teams in Singapore that are developing a data collection tool. So we're able to collect data and provide feedback around bottlenecks, how to optimize the movement of material around the warehouse or the factory or the facility. So we're doing that. We're also doing a lot of work around remote fix and putting some software on to the robot so that we can create a better customer experience for the end user. And finally, we're able to also add our financial assets to the sales effort, and we're able to develop robot as a service. So one of the exciting things we've been able to do is provide our customers the robots as a service. And that actually was one of the questions I wanted to ask Stefan around his product is what's your commercial model behind the drones? Is it per mission? Do you charge a service fee, or is it straight acquisition and licensing? How does it work?
A mix of robot as a service and straight acquisition in some cases. So yeah, definitely looking for that sort of recurring revenue model. And yeah, interesting to hear you guys are doing the same. Has its challenges, but benefits as well. Yeah.
I suppose,
Absolutely.
Andrew, that's a good question for you as well. What's your commercial model around the technology and how it's deployed? Do you sell it or lease it?
Yeah, I mean, normally for a pilot product, we do lease, right? Just to understand the users and how you're using it. But after that, you know, if there's a bigger take-up, then yeah, we do sell the kit.
Yep.
Yeah.
Obviously, there's a bit of training involved as well in the technology.
Right. Train on the local domain and understanding the terrain and all that, right? And how, as you know, I think all the robotics experts here, you know, to actually deploy autonomous platform is not that straightforward, especially when you're operating in the midst of, you know, humans, right? Because so to get the robot accustomed to the scenario, I think it's an important part. So there's a part to participate in this phase.
That's a real key question. How much opportunity do you see here, you know, from an audience perspective for potential students and people who want to do a career transition? How much training? You know, I imagine, you know, we predominantly deal with cybersecurity. There's a shortage in skills in the cyber domain. How do you find it in the robotics and drones domain in terms of skills and the opportunity there? That's for the panel.
I mean, from my perspective, I think robotics is one area where it's great because it brings together different disciplines. I mean, obviously there's a lot of it is software, so there's software development from all levels, from the lowest level firmware all the way through to sort of high level mission planning and autonomy. Then there's mechanical engineering to build the thing, and obviously the electronics, mechatronics as well. So yeah, it kind of brings together those three different areas in one. So yeah, I think there's a reason why robotics sort of clubs and groups are so popular in schools, etc. Because it's, you know, kids just love to get their hands dirty with building stuff and writing code to see things actually happen in the real world, not just on a screen.
Yeah, it does bring it all together. Well, look, thank you so much for that. We will try to have you all again. I think, Raman, we're going to try and do a robotics episode and a couple of episodes as well, less on security, but more just on the tech. On sort of the humanoid robotics, I think, in our cities and infrastructure episode. Now, you would have seen my slides. I've been jinxed today for whatever reason, and my slides have been on auto cue. But let me please introduce, just to at least introduce the International Security Industry Council of Japan, James Angelus, President and Representative Director. It's on auto cue. I can't be bothered changing it now. James, please introduce you, Tokyo. Thank you very much for your time. We've been conversing, but I think we've been talking about potentially doing a quad series, bringing Japan, India, and Australia and some US colleagues together. Maybe your background briefly and introduce us to the International Security Industry Council.
Well, thank you, Chris, and thank you, Raman and Andrew and Stefan. Great presentations. Martin, you answered very nicely on the commercial side, and that's really where I come in. In Japan, there is no experience really in exporting defense equipment, very little in joint venturing other than with its U.S. ally. It is steadily gaining defense cooperation agreements, most recently with India, also with Australia, and with some of the European countries. There's a huge growing threat to the Asia-Pacific that we're all aware of, and it pretty much drives our new organization. Our writ is to put international partnerships together. And Japan has the technology, and Australia has the energy, and India has the volumes. Singapore has its intellectual, and Malaysia has its aerospace, and the rest of the countries also have their own very specific skill sets. We are going to first focus on the Quad, which is India, Japan, US, and Australia. We were really referring to the Quad Plus, which would involve the other countries who are valuable allies, if you will, friends and partners. This kind of discussion on the technology is at the core of everything we do, because it's relationship and it's building commercial bonds, but it's really all driven by the technology. So we are following that here in Japan. We're working with the Defense Technology Foundation, and their 60 years of experience, white papers and research and are regularly now beginning to make introductions between Japan and others. I'm not sure if I'm still on here.
Sorry, James. Yes, we can hear you. No problem.
Yeah, I've lost my visual, so I'm not sure if I'm new to this webinar, GoToWebinar. It's more complicated, and I lost audio, and now I've lost video, so I can't see anyone.
Well, look, if you could just maybe, your key partnerships. Obviously, it's interesting that we have you on for this episode, being in Japan. Japan's obviously recognised for its robotics sector, probably recognised world leader in robotics. I think they just launched. I should have had it up on my screens of the largest robot I've ever seen, a large transformer type robot. Maybe I think just before we kind of close off, where do you see the robotics sector in Japan and how it's potentially reaching out to the region? Is it ready to open up to partners in the region?
Yes, it is, but there are a few conditions to that. The first problem is language. And whenever we introduce people like we're doing now and we're sharing information, the pace of the conversation needs to slow down. The English skills are very difficult here. So the communication has to be solved first. The technology exchange is another issue because they have a lot of security fears about releasing certain information, and so there's a whole kind of a process of getting the exchange agreements in place. And these are all overseen by the two ministries, Ministry of Trade and the Ministry of Defense. So it's a very tough process, and it's not, one reason they prefer working with Australia is that they don't have on the other side, the IFTAR and other regulations the U.S. has for that same procedure. So it's complicated. The first step is to get acquainted, like we are now. The second step is to express interest in specific areas. And thirdly is to really then start the procedure. But,
well, look, James, what we'll do is I think we'll have you back. The audio is not the best, but I definitely can understand you. I think we've gone just about on time. We normally just go slightly over our 60 minutes. So what I'll do, I'm going to close the session. James, I know that we'll have you back. I wanted you to meet Raman also. So it's great to have Sydney, Tokyo and Delhi on the one session. I think we'll need to get San Francisco and Washington on next. And obviously our colleagues there in Singapore representing the ASEAN nations as well. And thank you to our Brisbane colleagues, Stefan and Martin. Raman, you're on mute.
Yeah. Thank you, Andrew, Mr. Martin and Stefan and Mr. James. This is one such webinar where I am forced to open my bag, take out my checkbook, because what you have shared is an opportunity I can see in India. And I'll send one of you a separate mail. The huge opportunity is waiting for you. Please connect with me. And yesterday we had India's procurement policy opened, both for defense. For Martin, you must get into the Indian hospitals. A lot of COVID hospitals waiting for you, and a lot of warehouses also. Stephen, I have told you, I'm going to get you the largest order. And Mr. Andrew, Singapore is going to fly away. Please come to India. And I request all of you to be in Bangalore in February 2021 on the Aero India show. And of course, Chris would be there to receive along with me. Thank you so much.
Let's hope my Qantas points last that long and we can actually get there, Raman. Look, thank you so much. We're going to close off on this particular episode. Andrew Yu from ST Engineering in Singapore, Stefan Hrabar from Emesent in Brisbane, Martin Keetels from Konica Minolta in Brisbane also, and James Angelus from the International Security Industry Council in Tokyo. Thank you very much, Raman. Pleasure. Thank you for joining us from Delhi. and we'll sign off now. Namaste. Thank you very much.
Thank you so much.
Thank you.
Good night, everyone.
Thank
This
you.
session's on My Security TV. It'll be out by tomorrow. I'll send you the links. Ciao.
Ciao.
Ciao.